All right, so for this lesson, we're going to talk about the 30, 60, 90 special right triangles. So the idea is you're going to take a look at this triangle that's shown here. We're telling you that this triangle down here is equilateral. So we know that if the triangle is equilateral, it's also equiangular. And equiangular triangles all have 60-degree angles. They're saying that we've got sides of 2 centimeters all the way around. If we were to drop an altitude from angle C, which makes a right angle, we'll call that D. It turns out that if we look at just one side of the triangle, once we've looked at the measures of the angles, highlighter, if we just look at this one particular side, if we have 60 degrees here in the corner, and then we've got 90 degrees over here at the altitude, that this angle right here in the corner is 30 degrees, which means this other angle is 30 degrees. So it turns out that by doing an altitude, dropping down an altitude, this altitude divides C into two congruent angles, each of those angles measuring 30 degrees. It also divides AB into two congruent segments because the altitude and the angle bisector also act as a median, which means this guy right here is 1 and this guy right here is 1. So as it turns out that if you have an equilateral triangle, your altitude acts as both an angle bisector and a median. Well, one thing you can probably notice pretty quickly is the length of the side opposite the 30-degree angle. If we just pull out a snapshot, just this left-hand side, we knew that this was 2 to begin with. We knew that this was 60 to begin with. Here's our 90-degree angle. Here's our 30-degree angle. This was the D. This was the B. This was the C. Well, DB ends up being 1. So what do you notice about the length of the side opposite the 30-degree angle? It's half the side of the hypotenuse. So it is 1/2 the length of the hypotenuse. Alrighty. So so now if we use the Pythagorean theorem to find the side of the leg that's opposite the 60-degree angle, excuse me. So remember, this was our equilateral triangle. We knew that was 2. This is our CDB. We know this guy right here is 1. How are we going to find this particular leg? Well, by using the Pythagorean theorem, we could say x squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. X squared equals 3, so x must equal the square root of 3. So this particular leg right here is just the square root of 3. What's happened is you have now, if we do a whole bunch of different equilateral triangles, we're going to find the same pattern that happens over and over again. And the pattern happens to be this. At any 30, 60, 90 right triangle. So we've got, let me fix this a little bit. Make it draw more the way that we see it. Let's do it more like this. So if we are in any 30, 60, 90 triangle, the length of the shortest leg opposite the 30 degrees is always going to take the expression of x. The length of the 60, the side opposite the 60-degree angle, is always going to take whatever the short leg is multiplied by the square root of 3. It's just a little bit bigger than that leg. And the hypotenuse, the length that's opposite the 90-degree angle, is always going to be double the short leg. So this is what you're going to have memorized for 30, 60, 90 special right triangle, is that the short leg, no matter what, is always going to take length of x. The leg opposite the 60-degree angle is going to be x rad 3, and the leg that's opposite the hypotenuse is always going to be twice whatever that short leg is. So let's try and do some math here. Find the missing sides. Just like 45, 45, 90s, I think it's really important that you label all the way around. So here's our 30 degrees, which means this value should be x, this value should be x radical 3, and this value should be 2x. You should be able to look at it and figure out what's happening, but I will show you the algebra. The fact that the 2x, the hypotenuse side, is equal to 14, well, that just means x is equal to 7. So our short leg is 7. The fact that opposite 60 is x radical 3, all you're going to be doing is taking in what the value of x is and dumping it in. So that particular leg right there is going to be 7 radical 3. That's one of the easy ones. Let's go to this next triangle. 30, 60, 90. Opposite 30 always takes x. Opposite 60 takes x rad 3. And opposite the hypotenuse takes 2x. Well, let's do the algebra again. If x rad 3 equals 5 rad 3, and I want to solve for x, well, I divide both sides by the square root of 3, and x is just equal to 5. So my short leg then is just 5. Well, all I have to do to my short leg is double it, which means 5 times 2, or my hypotenuse is 10. Next one, again, 30, 60, 90. Opposite the short leg is x, opposite the longer leg, opposite 60 degrees, is x rad 3, and opposite the hypotenuse is twice x. Well, they're giving you x to be 4. If x is 4, then opposite 60, whoopsie, not 2, opposite 60 then becomes 4 rad 3, and then the hypotenuse becomes double 4, or 8. Last but not least, excuse me, opposite the short leg is x, opposite the longer leg is x rad 3, and opposite the hypotenuse is 2x. So we're finding out that the x rad 3 side is equal to 12. Well, how do you get x all alone? You divide it by the square root of 3. But the problem is, again, and we've learned this from algebra, and we talked about it enough this year, that you can't have a square root in the denominator, so you need to rationalize it. The only way to get a square root to go away is to multiply it by itself. By doing this, you're going to get just 3 on the bottom. Up top is just 12 rad 3. And then when you do your division here, you realize that, well, 12 divided by 3 is just the same thing as 4. And what you're left with is just 4 rad 3. So then it turns out that x is just 4 rad 3. And then if you were to double 4 rad 3, you just get your hypotenuse to be 8 rad 3. Something that's also very interesting about this particular 4 rad 3 piece, or at least the 12 being equal to x rad 3, is we talked about the shortcut with the 45, 45, 90s. To get rid of a radical 2, you divide by 2 and multiply by rad 2. It's the same thing that happens here. So if you wanted to apply the shortcut, let's kind of do this real fast. You know that 12 is your x rad 3 side, but to get to x, you'll divide it by 3 and multiply by a rad 3, and that gets you down to 4 rad 3 anyway. So you can do the work algebraically, or you can do the shortcut. It's entirely up to you. Okay, so that's it. Homework, hopefully you should be good on. Again, I would label all your sides. You've got a couple of word problems here. Notice how on this last one, you're dealing with a 45, 45, 90 on this side and a 30, 60, 90 on that side. Okay, so I think you guys should be good. So good luck on the homework, and then that's it. We are done. And we should be ready for our quiz this week on 6-1 Pythagorean theorem, 6-2 45, 45, 90 right triangles, and then 6-3, which is 30, 60, 90s. All right, have a good night.